2, 3, funky.
Hey you guys, welcome back to the channel, and in today's I'm going to be going over the calculations for coefficient of frictions and weight and all that related stuff. And I hope you guys are having a good day, and without any more talking we can just get started. Okay, so here is just a free body diagram if you guys need something to reference really quickly. I could go over it like really quickly. So the normal force is also equivalent to the weight of an object because it is the force that is holding an object up, while the gravity force down here is trying to pull the object down. And they're basically a pair of reaction-action forces if you ask me, because they're both balanced, you're holding the object together, they're equal and opposite in directions, and yeah. And then the friction force is the force that is trying to oppose the applied force that you're putting into an object to get it to move. And those are sometimes equal when an object is at rest or at a constant velocity, but it's not if an object is decelerating or stopping. Then your friction force is probably bigger than your applied force. But if your applied force is bigger than your friction force, then your object is supposed to move and accelerate. Okay. So now let's get into some of the basics that can help you guys understand how to calculate weight and normal force, because they're going to ask you how to not ask you how to do that, but they could ask you a problem. You know what? Let's calculate it and we'll get into that later. Okay. So it's asking you a 30-kilogram brick is laying on a table, but it's not moving. So what is the normal force? So we know that normal force is equivalent to the weight of an object, and we know that weight is equal to mass times gravity, and gravity, if they don't tell you otherwise, is 9.8. So we know the mass times gravity, and your answer is 294 newtons. Next problem. What is the weight of a 36-kilogram person on Earth? So gravity on Earth here is 9.8 times the mass is your weight of 352.8 newtons. Next, we have what is the weight of a 12-kilogram dog on the moon? So in this case, it tells you otherwise, and the gravity is 1.63 meters per second squared. So mass times 1.63 and it's 19.56 newtons. And yeah, mass and normal force are the same thing, so whichever way they ask you that, you just multiply the kilograms, which is the mass, times the gravity, which is represented by meters per second squared. So let's start with this problem here. A box takes 40 newtons to start moving when the coefficient of static friction is 0.54. What is the weight of the box? So it's asking us what the weight is, and we know that weight is also equivalent to the force of normal force, or is also equal to the force of gravity. So these are always equal to each other. And so if it's asking us that, then what we know is that the applied force is 40 newtons, because that's the amount of force that it takes it to start to move. And we know that that is equal to 0.54, which is the mu. And so what we don't have is the weight, so the normal force. And so in this case, what you want to do is you divide. So 40 divided by 0.54, and your answer would be 74.07. I totally forgot the 7. Okay, 74.07 newtons is your answer. And it's as simple as that. You just always have to have the equation in front of you, and that will make it so much easier to just plug in and just kind of think a little bit and solve it. So, the next problem. And normally in physics, they don't usually just tell you stuff straight up. You have to kind of think and use your brain and like put stuff together. And you're going to see an example of that in this problem here. So a 50 Newton crate is sliding along a horizontal platform at 3 meters per second. The coefficient between the crate and platform is 0.2. And what is the magnitude of force exerted on the crate? So if it's asking you what the magnitude of the force exerted on the crate is, we know that we're trying to find the applied force because that's the exerted force. If that makes any sense. The force you're exerting on the crate is the force you're putting on the crate, so your applied force. We know that 15 newtons is equal to the weight or normal force. And then we know that 0.2 is your mu, because it's normally usually a decimal. So that's your mu. And we know that your crate is sliding at 3 meters per second, and that represents velocity. So it's moving at a constant velocity of 3 meters per second. So we know that we can replace the equations of force of friction is equal to mu times normal force. We can replace that with applied force is equal to mu times the force times the weight. So we can replace those equations because we know it's moving at a constant velocity. That makes any sense? Let me write the equation out for you guys so you guys don't think I'm crazy. That's your mu and the normal force. I'm going to put a capital letter. And then your other equation is applied force, mu times force of weight. So if your object is moving at a constant velocity, then you can't replace it with this one down here. Okay, and that's what we're going to do in this problem because it's moving at a constant velocity, so we can replace it. So is for the question mark is equal to 0.2 times, if I could find something, okay, times 15. And when you multiply that together, 0.2 times 15, you get 3. So your applied force is 3 newtons, and that's that. A 220 kilogram crate is pushed horizontally with a force of 700 newtons. If the coefficient of kinetic friction is 0.2, calculate the frictional force acting on the crate and determine if the crate is accelerating. Okay, so we have, what we're going to do is we're trying to find frictional force. And we know the frictional force is equal to your mu times your normal force. And so frictional force is a question mark. And that is equal to 0.20, because that's your mu, your coefficient of kinetic friction. Friction. And then you have to multiply that by your normal force, which is your weight. And we don't have that, which is why I was going over those conceptual stuff earlier with the calculating weight, because in physics they normally like to do that. So they give you the mass, so they expect you to find the weight, which is also the normal force. So all you have to do is 220 kilograms times 9.8, and that'll give you 2,156. And then when you multiply that together, it's going to give you 31.2 newtons, and that is your force of friction. And like I said earlier, if your force of friction is greater than your applied force, it's not going to move. If your applied force is greater than your force of friction, it's going to move. In this case, the applied force is 700 newtons. Force of friction is this. So the car is going to accelerate because you're putting in more force than the force of friction, so it's going to accelerate. And then for the last problem, we have a 5 kilogram block of cheese is accelerated horizontally across a tabletop. It is pushed on if the coefficient of friction between the cheese and table is 0.33, what amount of applied force is necessary to do this? So you're trying to find applied force, named that is 4 times force of that, and so we don't know what that is. Put a question mark for it. Is equal to your mu, which is 0.33, times your weight, and weight is mass times gravity. Girl. Okay, so 0.33 times 49. Your question mark, which is your applied force, is equal to 16.7. Oops. 16.7. Wait, what was the answer? 16.17 newtons. And What amount of applied force is necessary to do this? So if your
A few moments later.
what amount of applied force is necessary to do this? So your applied force, if you want your cheese, your block of cheese to accelerate, then you would have to have your applied force be greater than your frictional force, or it's not going to accelerate. If they're equal, they could move at a constant velocity, but the question is asking how much is needed to accelerate, and to accelerate, your applied force has to be greater than your friction force, and that is the answer. Let me write that down. And yeah, that's just that on that. And I hope you guys enjoyed this video, or you found this video helpful, and I will see you guys in the next one. Bye guys.
Are you not ashamed of yourself? Are you not embarrassed? This is really embarrassing.
What amount of applied force is necessarily... Why did I read Okay. Oops. Anyways, okay, so that's that. And so now you are trying to... I'm moving too fast. Okay, let's not sing.